So many companies are turning to productization as a means to improve returns through lower costs, shorter cycle times. This focuses squarely on the product design lever of project production management. Today, we have Kathy Farina, who's the Vice President of DieCat Solutions, a company which provides innovative solutions to heavy industry business sector, to tell us all about it. Kathy facilitates workshops and alignment sessions with customers using DieCat's 4 innovative solutions: modularization, facility standardization, lean design, and execution. Using these solutions, they enable the ability to achieve capital efficiency on programs and projects. She has 25 years of experience in the oil and gas, petrochemical, and mining industries. And most recently, she's been working with global customers, providing expertise, training tools to implement modularization, lean design, and standardization on their projects. So well qualified, and we're looking forward to you sharing your thoughts with it, Kathy. So I'll turn it over to you.
Oh, thank you, Gary. So welcome, everyone. We're going to talk today about developing a business case to productize. And we've actually heard a little bit about productization throughout this technical conference already. So some good examples I'll bring up as we're going through here. So I'm just going to go through. I've got lots of content. We're limited time, but we're going to talk a little bit about the future of industrial capital projects, and then really touch on what is industrial productization. We're going to go and talk about what's the benefits. So we're going to touch on those benefits. Then timing to decide to productize, and then developing that business case to productize, which is very important, kind of as a starting point if you are looking at productization for your companies. So I'm going to dive right in. So right now, the future, we're really looking at the heavy industrial construction projects. We need to be more predictable. There's a lot of companies out there that really want it. It was about reducing capital costs. That's still important, but a lot more about project predictability, having that cost and schedule certainty, and that time to market. So what industrial productization really does is it really helps, and this has been proven for some different cases, but helps improve that rate of return for companies when they're looking at programs and repeatable projects than a traditional custom design build method. And also reduces that program and project risk, which is really important nowadays with the labor market and these time to market types of conditions and constraints. So it also improves the safety and quality. And that's another important aspect that a lot of companies are now looking at, locations of where some of these facilities are going in, is improving that quality and safety. And then environmental sustainability, or environmental, social, and governance. That should be social in there, strategies. A lot of now companies are looking at the ESG components and targets that they need to meet. And industrial productization also contributes to those as well. And I'll go through a little bit on why here in some of the later slides. So what is industrial productization? It really is, the productization really is defined as a process of analyzing a need, defining and combining suitable elements into a product-like object, which is standardized, repeatable, and comprehensible. That's a definition back in 2015. What industrial productization really is looking at the process of designing and building either a process facility or sections of a facility, or even equipment in a facility that can be replicated for installation of other types of facilities or sections of facilities. What we really do is we apply those lean, sustainable design and execution principles, and a lot of presentations have already talked about some of those different types of methods that you would apply. And it also combines standardization and modularization to create kind of some different components that you can use to install either of your facilities or your sections of facilities. So some examples that I'm going to give out is LNG trains. So LNG trains are very, very, they lend themselves to productization. So just, you can standardize the train, and then you just have to, if you have 2 or 3 or 4 trains, those would be kind of repeatable components that would be productized. And it would be much more, after you do the first one, you can actually really repeat and provide that productization for the second, third, and fourth one. So LNG trains are a very good example. We heard about small scale modular nuclear reactors. And that one is actually becoming more and more right now looked at. And so that's another example of a productization, using productization, a product-based approach. Small scale LNG facilities, small scale renewable gas facilities, compressor stations, well sites. All of these are examples of really good repeatable facilities that can use productization. Data centers. We just heard one around data centers. So these are all really good examples of what some industrial facilities really can look at with regards to productization. So what it does is it combines that modular design, which we heard earlier around the nuclear, small scale nuclear facilities. And modular design really is that section or block of a facility that is fabricated and assembled in an offsite location from an installed location, so in a more controlled environment. And there's a lot of different variations of what you can do with a modular design, whether it's pre-assemblies or full modules. But that is kind of one of the key components with a productization approach. And then standard designs are that design that has that process envelope, or that design envelope that is engineered and authenticated once and executed many times. And that's where you combine with the modular and standard design, you get that industrial productization. Just an example, this is a case study that was for a well facility, an oil well facility. So it had multiple well pairs on this facility. And what we did with this program is we productized it. We productized some of the key modules that would make up this specific facility. And you can see here, you've got a pipe rack module, inlet standard module, and then well pair and electrical station module, as well as a separator module. And these were a catalog. So they were completely standard. And you could pick from that catalog to create the facility depending on how many well pairs they were. And this is just the example of the completed facility for a specific well site. And so what we would do is we order 3 pipe rack modules. We would order 6 well pair modules, an electrical station module inlet, and then a separator. And they were all standard, and they would get tagged when they got to site. So this is really this is an example of taking productization in an industrial environment to the full capability that you can perform. So it's combining that standard and modular approach. So some benefits that we want to kind of take a look at. Why would we want to do this? Why would we want to look at industrial productization? It's that cost and schedule certainty that's becoming more and more important for companies and for owners and for projects, is making sure that they actually can perform and meet that cost and schedule that the project is promising. And also reducing that program and project risk. So that's another key component to now more future of capital projects and construction projects, is that reducing that risk. And industrial productization does that by really being able to standardize processes, procedures, equipment, the designs. So you know exactly how much it's going to cost, and you know exactly how much time you're going to need. And you work really closely with the vendors and suppliers and the contractors, all within that whole program, to be able to effectively put in a full productized program for your facilities. You have reduced capital costs in most cases, and because you're modularizing, you're moving that work off-site. Depending on where you are in the world, you will see some reduced capital costs there, but also in the standardization component. And that is because you are now reducing your home office hours, because you are providing standard designs right up front. So you are standardizing. You are actually reducing your cost for your procurement you can have bulk savings, so bulk purchasing. And also you're reducing that approval time to get that equipment to market. And then you're also looking at improved, more efficient fabrication and assembly for your modules or your components, because they will already have that standard in, and they actually are able to go right to fabricating and assembling these modules without having any pre-work to do with spool drawings or steel cut sheets. All of that is already done. And then they can actually be more efficient in their overall process. They actually really truly can go to a manufacturing type process. And again, it does depend on what yard or what facility you do go to, what manufacturing facility you do go to. But that's where you'd want to definitely employ someone that can do that more manufacturing type process. You're going to have that improved schedule performance because again, you're removing a lot of the upfront engineering, a lot of the upfront approval processes, and you can actually go straight to fabricating these modules or these components that will make up your facility. You'll have improved safety performance and quality because you are moving your work into a more controlled environment, and you're also minimizing the rework because you do have those standardized designs and processes already in place. So that is that really has attributed to a higher improved quality that we have seen as part of some of our previous case studies. Some proven plants that have employed this. Improved sustainability and ESG factors. We talked a little bit about that, but if you are modularizing and using a little bit more of a lean design, you're reducing that waste in your design. You're reducing your plot footprint, and you can actually lead to reduced carbon emissions if you are looking at doing your layout a little bit differently, not a traditional stick-built layout, but actually modularizing it, doing a modular layout. And also, you actually have reduced use of hydro-test water at the module yard. You actually can reduce construction vehicles and equipment at the site because you are moving some of that labor off-site. And then overall, reduced facility lifecycle costs. This goes into your operations and maintenance. When you standardize, you're going to have standardized procedures. You're going to know where those valves are. You're going to know where those panels are. Operators can go onto any plant or any facility in that area or any train and know exactly where they're going and how they need to, what they're looking for. And we've got some proven costs on savings for operations and maintenance, because also you can contain your maintenance is very much, you can catalog what you need because it's all standard. And then the focus value improvement program is really looking at lessons learned, and you actually have a program for a productized approach that you actually get people to put in their value improvements and any lessons learned and any things that can optimize the design for future generations of the standard. So you're actually working on a focused continuous improvement program because you will put another generation of that design out eventually. And that's kind of working in the background. I'm going to go probably a little bit faster. Timing to decide to productize. On this slide, I really just wanted to really emphasize you need to do it earlier. It's typically with the owners companies. You need to really look at why you want to productize, and also I'm going to go through the business case on kind of the specific things that you need to look at in order to effectively make that decision to productize and be successful. As you see later in the phases, you will reduce those benefits I just talked about. Those reduced benefits will go, and they won't see as much, especially for the first one. But for the second one, if you can get it in there and you do the first one and then the second one and maybe the third one, you'll start to see some of those benefits. But right up front, to be the most successful, do it as soon as like when you're looking at the overall program of your repeatable facilities or components or trains. So developing that business case to productize, really what you need to do, we do these in 4 steps essentially, is you need to define those productization business drivers, and those are very typical of those benefits we just talked about, including a market analysis. You really do need to do a market analysis. Where are you going to be installing these products? Are they going to be global? Are they just going to be country specific? Where are some of those locations, and is there a market for it? Is there going to be a market for it in 10 years? Is there going to be a market or 5 years and 10 years? You really need to put that market analysis for the product right up front. And that should be all done the very first thing that you do to develop that business case. And then developing the productization concept, you really need to understand what you're going to be productizing and that concept, how much modularization, how much standardization, a little bit about technology around that concept to be able to effectively make the decision on whether it's the right decision to productize or not. And then a cost analysis and risk analysis, those are also most very important. You need to understand is what's that cost going to look like? Because there will be some cost additions, there will be some cost reductions, but what's that cost going to look like? And then the risk. So, is there any additional risks that need to be addressed? That's also very important. And then the one thing I want to talk about before you even get into this is you need to have management commitments. So the commitment to actually go down the productization route is very important. It makes sure that you have that executive commitment, and that will be able to align everyone, the program team, the program management, everyone on the goals on why you're productizing. So the management commitment is very important before you even start down this route. The business drivers, I'm not really going to go into these details because I did talk about the benefits already. And a lot of those benefits really lead into those business drivers. But the one thing that we are seeing, and I've talked a little bit about already, is that reducing that project risk, and also achieving or improving that internal rate of return for that program or projects. Those are kind of some of the key business drivers we've seen. Some of these other ones are also business drivers. We're seeing more and more come into play. ESG is becoming more important, as well as safety and quality. So some of these are also going to be part of that business driver to productize. And reduce time to market. A lot of looking at how fast can I get this product to market, so you start seeing revenue, and then you can phase it. For mega projects, if you're going to do it now in more stages, then you get to market, you get some revenue, and then you put the next phase in. Same with similar to like LNG trains. So defining that productization concept, I've got the kind of 5 steps or 5 things that you need to look at here. The first one being the module concept. Then that is really looking at what was your module kind of size that you're going to be able to transport, as well as what's going to go on the modules. What does the module layout look like? So how are we going to orientate these modules? So what size can you ship, but also how much percent modularization are we going to include in this specific product? So it's really looking at, you got to look at the locations, the locations of where this product's going to go, or this facility is going to go. And what are some of those transportation logistics constraints at the site specifically, around the site, but also looking at space constraints. And is there any, are we close to water? So if it's more of a small scale plant, most likely it's going to be inland. Most likely you're going to be shipping smaller modules, truckable modules. If you're, say, an LNG train and you're closer to water, you'll have the ability to actually ship larger modules, maybe very large modules, because you're close to that water. So this is all takes into the consideration for the module concept. Also, any technical constraints. So when you're looking at what equipment that you're going to be putting on these modules, these standard modules, you need to make sure that you have the specifications, and any of your specifications essentially they address putting, say, pumps on modules, or using distributed electrical, which is something that you could utilize in your module concept. And then looking at kind of that labor availability as well. So that may drive you to do more modules for your facility or for your product, because there isn't the labor availability in the regions that you're looking at, or the productivity is extremely low. And the rates are high. So some of those things they're going to drive your module concept. Technical data is going to really be looking at now your ranges. So you're going to be looking at your production rates, inputs, and outputs. You really need to understand those. Your geographical limitations like seismic and weather considerations. Your regulatory and environmental considerations for the proposed locations. Are you going global? Or are you just going country, like we said, or region or province? That will all play into how much you can actually standardize and how much you can modularize. That technical data will play into that. Any of your process standardization for your automation, your local electrical and control standards, your local engineering requirements, all of that's going to play into how you're going to develop this product and this standard. The next one, technology maturity. We're looking at kind of how mature is your technology, because you don't want to put an immature technology in and try to create a product with it, because it will change. So the risk of change, and then you're going to actually, all that work that you put into developing that product will actually have to be changed. So you really want to look at something that's a little bit more mature, flexible, and it is maybe scalable. So technology maturity is going to be very important. And then you're looking at the degree of standardization, the number of standard modular units and facilities. And this plays into, this is a little bit around the standardization side of things. This plays into Are you going to just do equipment and components? Are you going to do, say, packages or subsystems, or do more modules? Like we would recommend really when you're looking at products to go to that modules, but you can do pre-assemblies and some packages as well. Are you going to do the complete facility? What I showed you the example earlier was that complete facility, except for, of course, the below ground, but the above ground surface facility components were all standard, including the plot layout. And locations of all the undergrounds were all standard. It's just the actual undergrounds were site specific, depending on what location we were. So this is the kind of levels of standardization that you can see. So if you're doing equipments to components, you're about 25%, the packages around 50%. If you're doing modules as well, you're going to get about 75% modularization for your facility. If you're actually doing the plot plan and you're doing standard kind of layouts and spacing, you can actually get to the complete facility, which is about 85%. Again, you're never going to get 100% modularization or standardization. It's just not practical. You will always have some site-specific components because you'll be going to different locations. Okay, I'm going to try to speed it up a little bit. I think I've got a couple minutes here. So cost analysis, this is something that you also have to perform. So you've got your productization concept based on a bunch of different factors that you need to pull together and pull to get that concept itself. And then you'll get your productization strategy from that productization concept. But the cost analysis, really, when we're looking at it at a high level one, because you're earlier on in the program or project, you're looking at comparing it to a historical custom stick-built traditional project and seeing what those cost savings could be based on doing a more productized approach. So you'll have some cost savings, and that's going to be labor rates and productivity, because you're going to be manufacturing some of these components now. You're going to have some reduced engineering costs, as well as the manufacturing costs for repeatable facilities, as well as the volume discounts for procurement. All of those will play into your cost savings. And you will also have construction savings as well, because you will have some standardized components on the site construction, because they will know and be able to plan a little bit more effectively and efficiently. It's a much more efficient execution. You'll have to look at your schedule factors, and that's, those reduced schedules for those repeatable plants after that the product's been developed. You'll be able to reduce your schedule anywhere from 30 to 50%. That's what we've seen in some of our previous projects. We've been able to save anywhere from 10 to 20% in TIC. So some of those you'll need to look at to perform the overall cost analysis. And then your material cost reduction based on an optimum module layout. So reducing quantities, because you're now putting things much more closer, much more compact. And then you'll have some cost additions. And that's going to be your cost of your first product that you're developing, that product development, that cost to develop it. You will have that cost that's in there. And you will also have some costs for transportation logistics and some of those other ideas or other components that would lead to the cost. Just as a note, that you will also, the standard that you're doing I think they touched on a previous presentation on this, is that you will have ranges. So your design envelope will have ranges, and you may have one facility that may be slightly over designed and maybe one that's slightly under designed. And that's kind of those trade-offs that you need to look at, right? So you will have some of those components because you are now designing within a range. And then just the last one being the risk analysis. This is just looking at any additional new risks that the strategy may bring in. And we've got a lot of lessons learned on this. So we actually do a lot of training that's based on previous project lessons learned. But there are some new risks that you need to definitely address. And it's a different execution and a different design methodology. So making sure that that's understood on the project or program team that's working on this is very key. You do need a little bit of expertise to set up this execution because it is different. And if you just go down a traditional way of executing and designing projects, you will not be successful. So the key thing around the risk analysis is understanding those differences and making sure you address them in your execution. And then after you get all those components together, you actually have all the information to make an educated decision whether this specific program and facility or components or trains can they be productized? And then you make that decision, and then you either say yes, if in most cases it is yes. If you have repeatable projects or facilities, like some of these small scale plants coming out, it definitely makes sense to productize. But now you have the backup to say yes, this makes sense to productize. And then some cases, if you have some just very minimal repeatable product, the components, it may not make sense to productize. So then that would be a no. So that's the kind of end of the workflow on the business case. And then the path forward, I just wanted to say, we really need to look at how these 5 pillars of the project production system can really be implemented right up front in the product development, when you're actually doing the product development and the execution and design. So just as a path forward for myself, and for what I would like to be looking at is more, how can we really look at how we can implement and integrate this type of the system into the process and execution. And that's it.
All right.
I went really fast, so stop sharing here.
Okay, we got time for a couple of questions if we get any floating in here. I'll get the ball rolling with one. How do you overcome resistance from operations and maintenance to a productized, modularized facility?
We included them right up front. And I'll say it was difficult to be the first, when we were doing the product development, it was difficult because they were so used to custom type components. So everything was customized. But once we brought them in, we made sure that we addressed any of their operations and maintenance issues. We had a material handling matrix, so we know exactly how we're going to maintain this plant. So once we get the product and then we got the first plant in, then they went around and we did a lessons learned. So we went, the very first facility that got put in, we did a lessons learned, and then we incorporated those lessons learned for the second one. So it really did. And we had 5, I think we were on the 7th standard facility, and they loved it. Operations and maintenance loved it. It was they said they could bring on an operator and train them in no time, and they know exactly where everything was because it was all standardized.
And you had the same components, same valves.
Same components. Maintenance loved it because they had an inventory of that.
Yeah, that's really smart. Okay, well, that is really good. That's very insightful, and we look forward to working with you down the road with the Institute to help you expand and bring production management into your thinking.
Thank you. Yes, absolutely. Thank you very much, Gary.
All right. Thank you.